This is the continuation of my previous video on using proteus to understand current divider. In this video, I'm not going to use proteus. You're going to understand and solve the current division problems. I'll be making two videos. This one will be the simple one. The next one where I'm going to solve more complex problems. You can still use proteus to verify your calculation. So in this video, you're going to learn how to solve current division problems using the simple circuits. When I first showed you how to use proteus to understand the division of current in an electrical circuit, we came across two scenarios. The simplest and the first scenario is where there are two resistors in the circuit. Take this as an example. We have got two resistors in parallel, and keep in mind, in order to divide the current, you must have the resistance in parallel. Now here, the current I gets divided into two branches. One, the branch with the resistance R1, and another one with the branch with the resistor R2. So let this be current I1 and I2. We have seen this formula in my previous video. So the current I1 is the other resistor divided by total resistor times the main current. So it's good that you memorize this formula. Just say other resistor divided by total resistor times the input current. So that will give you this formula. So the current I1 is equal to, that's the I1 in the resistor R1. So the current I1 is the other resistor, that is the resistor R2, divided by the total resistor R1 plus R2 times I. Similarly, if you memorize this formula, the current I2 will be other resistor divided by total resistor times I. So that will be R1, this is the other resistor, divided by R1 plus R2. Now you can memorize this. Probably if you come across a problem that has got only two resistors, you can just directly fit in this formula. So other resistor divided by total resistor times the current. Now when you got three or more resistors, again the formula is very simple. So you have to first find the equivalent resistance. Because the resistors are all in parallel, so this is the quickest formula. If you're using calculator, just use this, the inverse of R1 plus inverse of R2 plus inverse of R3, so on, inverse of the last resistor, the whatever the sum you get here, inverse the answer. Is very easy to do with your calculator. So you first have to find out the total equivalent resistance of this parallel circuit. Then the formula will be the current I1 will be the total resistance divided by the resistance R1 times I. If you want to know the current in R2, the total resistance divided by the resistance in this branch R2 times I. If you want, similarly, if we keep applying this formula, if you want to find current in this resistor R3, so you'll end up getting, so will I3 will be equal to the total resistance divided by the branch resistance times this current I. So I have a simple example here. We have a current source that's 2 amps, and you have been asked to find the current through resistor with 400 ohm and the current through this 500 ohm resistor. So just have to apply the formula. The current in I1, or the current I1, is the other resistor divided by total resistor times the current, that will give 1.1 amps. Similarly, the current in here is the other resistor, that's 400 divided by total resistance times 2, that is 0.9 amps. So it's very straightforward. Now one more simple example. We got a 5 amps current source, and this time we got a equal resistance. So we got 2 kilo ohm and 2 kilo ohm. So the current I1 is the other resistor divided by total resistor times I, that's 2.5. Again I2 is the other resistor divided by total resistor times 5 is 2.5 amps. So because the resistance are same, the current is divided equally. So you just have to remember this type of concept. So this is an example where there are 3 resistors. So you have been asked to find the percentage of current in each resistor. So you just have to first understand what this circuit diagram is all about. So we have a current source and we have a 3 resistors in parallel. So obviously this is a current divider. Now if you have 3 or more resistor, you have to first find the equivalent resistance. So if you are using a calculator, you can do exactly what I've written here. So 100 inverse plus 500 inverse plus 800 inverse, the whole thing inverse, you get 70.5.5 ohms. So you know that in a parallel resistance, the total or the effective resistance is always less than the smallest of all the resistors. So the current in this branch I1 is, we know this formula again, it's good to memorize that the total resistance divided by the branch resistor times current, which is 3.78. Similarly, the current I2 is here the total resistance divided by the branch resistance times the main current, you get that. And here also the current I3 is the total resistance divided by branch resistance times I, that gives you that. When you add this all, you will end up getting a few decimal errors here. So you have to bear with that, and you know that because these values are approximated values, so you might end up getting few differences. But the actual question was to find the percentage of the total current. Now again, this is a simple math. You might have done that in your earlier school. So the percentage of the current going through this I1, so that will be, so the current I1 divided by the total current times 100, so that gives you 75.6%. Similarly, when you apply the same thing, you'll end up getting 15.5 and 9.4, so all should add up to 100%. Again, something basic you have to remember here as well. The branch that has the lowest resistor will have the most current. So if you look at this current I1, which is 3.78 amps, which is more than the other branch current because the resistance is lesser than all the three. This is one more similar problem with the little twist. You have been asked to find the values of the resistor to produce the following percentage current through the branches. Now what it says is what values of resistors you have to put in order to have 25% of the current through the resistor R1 and the remaining 70% of the current through resistor R2. Now again, this is a 2 resistor problem. Remember the formula. The current in a branch is the other resistor divided by total resistor times the main current. Now if you apply that logic here, so the current I1 is the other resistor R2 divided by total resistor RT times I. See, we still don't know the value of the total resistors or all these resistor values. You just have to find out, but you will find that eventually everything cancels out. So if you simplify this, so you know that you have been given the current through R1 is 25%. So I can just write that I1 will be 0.25 times the main current I. So again, you can say when substituting that, now I and I will cancel away. You'll end up having, so 0.25 is equal to R2 by RT, or 0.25 RT is equal to R2. Again, this is just the first equation you got. Apply a similar method for the current in R2. So I2 is the other resistor divided by total resistance times the current. You have been given the current through R2 is 75%, which is nothing but 0.75 times I equals R1 by RT times I. Now this and this will cancel away. You end up with 0.75 is equal to R1 by RT. Now again you further simplify, you get this equation 2. Now we got two equations, this and that. Divide 1 by 2 or 2 by 1, doesn't matter. When you divide 1 by 2, you'll end up having 0.25 RT by 0.75 RT is equal to R2 by R1. Now RT will cancel away, and if you replace this with integers, you'll end up having 1 by 3 is equal to R2 by R3, or R1 will be 3 times of R2. So now we know that resistance R1 must be more than R2 because the current through resistance R1 is 25%. So it makes sense that the resistance must be more than R2. So this is the main equation or the relationship you got between R1 and R2. A problem like that, they will ask you what range of values. So you can put any value as long as this relationship holds good. If you take R1 as 100, so R2 will be this other way, sorry, so something went wrong here. So if you take, say, R2 as 100, R1 will be 3 times of 100, that is R1 will be 300, because you know that R1 is 3 times the value of R2. Again, this is if you know how to apply these type of equations, easy to solve a problem with these percentage values. You can also apply a simple ratio concept for the previous problem. So we are given the current in I1 is 25% and the current in I2 is 75%. So I have written I1 is to I2 here as a ratio, which is 0.25 is to 0.75. Get the integer equivalent of that, that is 1 is to 3. And I'm just going to cross multiply or cross these things. So I'm going to get the ratio of resistance R1 and R3 is 3 is to 1. So just a bit of a trick, So we got the same answer when we did with the proper method, but this is kind of a shortcut. The first you take the ratio of the current, then you reverse the ratios to get the ratio of the resistance. So R1 and the ratio between R1 and R3 is 3 is to 1. If you give 300 ohms for here, so this will be the 100 ohms. So multiply. No, it's just a ratio. So here, one more example. If you want the current division as a 20% and 80%, so this will be 1 is to 4. Cross over that. So the ratio between R1 and R2 will be 4 is to 1. Now if you multiply by 100, you get 400 and this becomes 100. So the resistance value will be 400 and 100. This is just one of a value. If you multiply by 1000, you'll end up having 4000 ohm and 400 ohm. Still you get the current division of 20% and 80%. This is one more simple problem with the twist. So you have been asked to find what's the value of this resistor R to have a current of 3 milliamps. So again, first understand the circuit diagram. You got a current source with 10 milliamps. You got one resistor with the 2 kilo ohm, and the other one you have been asked to find. However, you have been told that the current in this branch must be 3 milliamps. Again, this is a problem with the 2 resistor, and memorize this. The current in resistor is equal to the other resistance divided by total resistance times the main current. If you apply this formula here, the current I1 is the other resistance 2K divided by total resistance, which is a 2K plus R times I. Again, put the values you have been given. 3 milliamps is equal to 2000 divided by 2000 plus R times 10 milliamps. Again, if you simplify everything, so you got a milliamps. I've written this 3 times 10 to the power minus 3, and here expanded 2k as 2000, and here also I've expanded the milliamps to 10,000 10 to the power minus 3. So when you solve this, you'll end up having the value of resistor R is 466.66 ohm. Now again, you just have to make sure the number you got makes sense. So you got the main current is 10 milliamps, and only 3 milliamps goes through this resistor. The remaining 7 milliamps must be in the other branch. So it makes sense that this resistance must be more than that. So we got 4666.66. Again, the main concept here is you have to understand this formula. This is the main thing. I have one more simple problem here. So it says determine the proper value of the resistor R2 in order to draw 20% of the total current. So you have been given some voltage source, doesn't matter what the value of this voltage source, and you know the resistance of one of the branch here, which is 1 kilo ohm, and the other resistance is R2. It is given the current through this must be 20% of the main current I, which is the main current over here. So you can apply a pure math here. We have seen this method just before this section. So the current ratio I1 is to I2 is, if I2 must have 20%, I1 must be 80%. So this will reduce to 4:1. Now in order to get the ratios for the resistors, you just have to reverse this value. So the resistance ratio between R1 and R2 will be 1:4. So again, R1 will have lesser resistance because 80% of the current will flow through R1. If you take any example, put any values for R1. If you take R1, in fact it's given here. So R1 is 1 kilo ohm, but R2 will be 4 times of that. 4 times of R1 is 4 kilo ohm. Now we'll try to do this applying the concept. So this concept we know already. The current in a branch is the other resistor divided by total resistor times the main current. So here the current in the branch, now you have to be careful what current you are speaking here. Now you have to find the value of this resistor R2. Now you must have an equation that will also have R2. There's no use of equation that has got R1. So that's the reason why I'm taking here the current in I1, which is 0.8 times of I, because if this is 20% of the current flows here, the remaining 80% must flow through R1. So 0.8 times of I is equal to R2 divided by 1 plus R2, which we don't know the value of R2, times I. Again, this is a basic math. When you simplify, you will end up getting equation like 1 equals 0.25 times R2. The value of R2 will be 1 divided by 0.25, which is 4 kilo ohm. So depending on what you've been asked, you can either use this quick method or you can show your skills using this method. I'm going to show you some of the simple ratio concept which you have studied in your high school level, how you can use this to solve some of the simple electrical problem as well. Now in your high school level, you have been told how to convert a ratio to fraction and a fraction to an expression and vice versa. Take for example the ratio x is to y is equal to 3:5. Now you know that this is the ratio you can always convert this into a fraction. I can make x is to y as x by y is equal to 3 by 5. When you cross multiply, you'll end up having 5x is equal to 3y. It's a very simple concept. Basically what we did so far is, given a ratio, you can convert that to an expression like this. So try to go from expression like that upwards, and you're going to get back the ratio. If you're given 5x is equal to 3y, get x by y is equal to 3 by 5. You can do that. You can apply your division. If you apply the basic math, you will end up doing that. Divide both the sides by y, you'll end up getting x by y, and you'll say that multiply by 5 and 5 will go away. So sometimes you can do this type of conversion mentally. So from this expression, you can get back the ratio x is to y is equal to 3 is to 5. Take one more example here. Assume that I got 0.2 R1 is equal to 0.5 times of R2. Convert this get rid of the decimal numbers here. I'm going to have 2 R1 is equal to 5 R2. Compare that we are here. We are at this point. Now we want to go one level up. So you'll end up having R1 by R2 is equal to 5 by 2. So you can always check when you cross multiply this and that, you must get the above expression. So R1 by R2 I can write as R1 is to R2 equals to 5 is to 2. Now this is something you can practice here. You can just, once you know this concept, you can mentally start getting these ratios. So 0.2 R1 is equal to 0.5 R2. So you'll end up getting, right, R1 is to R2. Bring these numbers, cross over these numbers. You'll end up having 0.5 is to 0.2, or you'll have 5 is to 2. So work out one more example. 0.3 R1 is equal to 0.8 R2. Now R1 is to R2 is equal to, this will go on this side and this will go on this side. I have removed the decimals, so 8 is to 3. One more, 0.1 R1 is equal to 0.7 R2. Again, take this to get R1 is to R2. Just take the whatever number you got against R2 into R1. So this 7 is to 1. Here I've taken the same problem we did earlier, but this time I'm going to use this concept of ratios and fractions we just discussed. So the first thing what we are going to do is just try to get simple equations. So the current I1, that is the current in this branch, is equal to 0.25 times I, and which is nothing but the other resistor divided by total resistor times the main current. If you start simplifying this, you'll end up having 0.25 is equal to R2 by RT, because I will cancel away, and I'm going to get the RT as the main variable here. So RT is equal to R2 by 0.25, or 4 times of R2. This is the first equation. Do the same thing for the current I2, which is 75% of the main current. So 0.75 times R is equal to the other resistor divided by total resistor times the current, 0.75, because here I cancel away, divided by R1 divided by, so 0.75 is equal to R1 by RT. Again, I'm going to make RT as the subject, end up having R1 by 0.75, which is again will give you 1.33 times R1. So we have got two equations, 1 and 2. I've written those equations here again. So first equation is RT is equal to 4 times of R2, and second equation is RT is equal to 1.33 times of R1. Because we have got both RTs are, we got RTs on both the equation, I can just equate 1.33 R1 is equal to 4 R2. So here we are going to start our ratios and expressions to ratio concept. I'm going to divide both the sides by 1.33 just to get the integers. You'll end up having R1 is equal to 3 times of R2, or R1 by R2 is equal to 3 by 1, because when you cross multiply here you have to get this equation. And we have seen how to convert an expression like this into the ratios. So ratio R1 R2 is equal to 3:1. I've written in the ratios below these variables. R1 is 3, R2 is 1. If you take any value, say if R1 is 300 ohm, R2 will be 100 ohm. So 300 is the R1 is the, this is more resistance, so you'll have lesser current. So just how to apply the basic ratios and fractions to solve these type of problems. There is one more concept in ratios which you have studied earlier that can be used to solve the electrical problems. So the concept here is, if you're given two ratios, A is to B and B is to C, find the ratio A is to B is to C. If you remember, the way you used to solve this is, first you write the A is to B on left hand side and B is to C on right hand side, and you try to apply the multiplication or division to make the B on left hand side same as B on the right hand side. Say for example, so once you make these two numbers same, you will end up writing A is to B is to C. Take this as an example. So A is to B is 3:6 and B is to C is 2:5. Now we have been asked to find A is to B is to C. So first step is, after you write in this way, left and right side, try to make the 6 and 2, the values here the same. So to make this same, you have to multiply the right hand side by 3. So when you multiply by 3, you'll end up having the right hand side as 6:15, because you have to multiply both the numbers. Now we got both 6 on the left and right side. We have equated them. After that, you can write the ratios as A is to B is to C is equal to 3:6:15. One more example here. You have been given X is to Y is 1:2, Y is to Z is 1:3. You have been asked to find X is to Y is to Z. So we just, as we did here, X is to Y is 1:2. So Y is to Z is 1:3. Now we need to equate these two. So we have to multiply right hand side by 2. So you'll end up having 2:6. Now these two are the same. So now we can write X is to Y is to Z is 1:2:6. And this is what I've written here. This again is simple concept. Next I'm going to show you how to use this method to solve one more electrical problem. So take one more similar problem here. I've got 3 resistors in parallel. You have been asked to find the resistor values to split the current as shown here. You want 10% of the current to go through the resistor R1, 30% through R2, and 60% to R3. So we have done this problem in the earlier part of my video. So here, because it's a 3 or more resistor, you will end up finding the equivalent resistance RT. So these are the formulas which you already know. The current I1 is the total resistance divided by R1 times I. The current I2 is the total resistance by R2 times I. The current I3 is the total resistance by R3 times I. Now first we are going to do, just apply, substitute the values given to you. So current I1 is 10% of the main current. So I got 0.1 times I equals RT by R1 times I. So I and I will cancel over here. You'll end up having 0.1 equals RT by R1. I've just missed one more point here. I could have written RT equals 0.1 times of R1 here itself. For the second equation, for the second branch, the current in R2, we have got 30% of the main current is 0.3 times I is equal to RT by R2 times I, which will again give you 0.3 equals RT by R2. Here you could have also got RT is equal to 0.3 times of R2. Look at that, RT and here RT as well. You can equate these two to get the ratios. Apply for the last branch, the 60% of I, 0.6 times I is equal to RT by R3 times I, which is equal to 0.6 is equal to RT by R3, and you could have got RT is equal to 0.6 times of R3. So with RT equal to all the three values, you could have equated all the three and get the ratios. Here I have gone with a bit of a lengthy method. So what I've done is divide equation 1 by equation 2, means dividing these two, you'll end up getting most of the things will cancel away. This and this will cancel away. I and I will cancel away. You'll end up having 1/3 is equal to R2 by R1, or here itself I can convert to ratio. R1 is to R2 is equal to 3 is to 1. So this is what we just discussed, how to convert a fraction to the ratios. If you apply the same method, divide equation 2 by 3, you'll have 0.3 divided by 0.6. I and I will cancel away. R2 will cancel away. You'll end up having half equals R3 by R2, which is, when you convert this to ratio, you'll end up having R2 is to R3 is equal to 2 is to 1. Now, after you do that, I've just written whatever numbers we got before. So R1 is to R2 is equal to 3 is to 1. R2 is to R3 is equal to 2 is to 1. Now we know that in order to simplify this, we have to have these two numbers as the same. I'm going to multiply the left hand side by 2. You'll end up having 6 is to 2 and 2 is to 1. Or if you put all together, the ratio between R1, R2, R3 will be 6 is to 2 is to 1. We got this exactly same number. Now if you put any value for R1, say multiply by 100, you'll end up getting R1 is 600 ohms, 200 ohms and 100 ohms. So that is all I've got for this video. I hope you got some concept out of this video. And if you want to know how I did all these slides, I have used Windows 10, the whiteboard in Windows 10. So hope to see you in my next video, which I will be showing you how to solve more complex problem and how to find the current in various branches. Thanks for watching.